Hello everyone. In the previous lectures, we discussed about the preliminary treatment of sewage and primary treatment of sewage and then secondary treatment of sewage. In this class lecture, we discussed about sludge digestion and septic tanks. Generally, solids handling system includes treating settled sludge in primary and secondary settling tanks. I told you that wastewater is equal to 99.9% of water plus 0.1% solids. This sludge is nothing but solids from primary settling tank plus secondary settling tank. Sludge, sludge, sludge is equal to, we can say, solids 0.25 to 12% plus water 88 to 99.75%. So this is the sludge. Sludge is equal to nothing but solids from primary settling tanks plus secondary settling tanks. Okay. If you take the moisture content, the raw sludge from primary sedimentation tank contains 95% moisture content. Secondary sludge from activated sludge process contains 98 to 99% moisture content. Secondary sludge from tertiary final will get 96 to 98% moisture content. What is the purpose of this sludge treatment means? Mainly volume reduction. Volume reduction means the moisture content will be reduced. Second thing, strength reduction, that means decomposition of sludge so that biochemical oxygen demand will be removed. Third thing, decomposition. 40 to 60% of organic matter is converted by bacteria into carbon dioxide and methane anaerobically. Sludge handling system contains the following things. One is the sludge thickening. In sludge thickening, we'll consider water removal or volume reduction. In sludge digestion, we'll consider organic matter strength reduction, odor control, gas production. And third one, sludge dewatering. Sludge dewatering is volume reduction. And fourth one, sludge drying is again volume reduction. And another one is the sludge incineration. Sludge incineration is organic matter strength reduction. Final one, sludge disposal, that is the land application and incineration. So in this lecture, first we'll discuss about the sludge thickeners. I told you that sludge thickeners minimizes the moisture content of sludge. Most commonly used sludge thickeners are gravity thickeners, where heavy sludge settles to the bottom and is carried into the digester. These sludge thickeners are simple and low cost, similar to the conventional sedimentation tank. Next, we'll discuss about the sludge digestion process. Sludge withdrawn from the sedimentation tank must be decomposed into a sludge digestion process. I told you that in the decomposition process, 40 to 60% of organic solids are converted by bacteria into carbon dioxide and methane anaerobically. Sludge digestion reduces the offensive odor and pathogenic contents and improves the sludge dewatering characteristics. Sludge gets broken up into three forms. One is the digested sludge, supernatant liquid, and gases of decomposition. Okay. So I told you sludge digestion gets broken into three forms. One is the digested sludge, supernatant liquor, gases of decomposition. First one, digested sludge, stable humus like solid matter with terry black in color free of pathogenic bacteria may contain cysts, eggs of bacteria, etc. Here, the volume will be one third of the volume of undigested sludge. It is dried up and used as a fertilizer. Okay. Next one, supernatant liquor. Supernatant liquid is a finely divided solid matter and liquid with biochemical oxygen demand about 3000 parts per million. Okay. Retreated in treatment plant along with the raw sewage. Okay. Next, third one is the gases of decomposition. Methane 65 to 70%, carbon dioxide 30%, other gases like nitrogen, hydrogen sulfide or evolved methane gases produced. Okay. Energy content of methane gas will be CH4 is equal to 5800 5800 kilocalorie per cubic meter. Okay. If you take the rate of sludge gas produced, that will be zero point 0.9 cubic meters per kg volatile solids decomposed in digester. Okay. So these are the three following forms the sludge gets broken up. One is the digested sludge, supernatant liquor, gas of decomposition. In digested sludge, stable humus like solid matter, and second one supernatant liquor, finely divided solid matter and liquid with biochemical oxygen demand about 3000 milligrams per liter, and third one gases of decomposition like methane 65 to 70%, carbon dioxide 30%. Okay. Next, coming to the stages of decomposition, there are two stages of decomposition. One is the acid fermentation or acid production stage, we say. Second one, acid regression. Third one, alkaline fermentation. First, acid fermentation or acid production stage. It is acidic in nature. Sludge reduced by acid. First, we'll discuss acid fermentation or acid production stage. Here, sludge reduced by acid forming bacteria. Here, bacteria is in both anaerobic and facultative type. Anaerobic means without presence of free dissolved oxygen, the bacteria will survive. And facultative means with presence and without presence of free dissolved oxygen, the bacteria will survive. Here, acidic fermentation, sludge reduced by acid forming bacteria. Bacteria is both anaerobic and facultative type. Next, second one, acid regression. Biochemical oxygen demand remains high during this stage. It becomes foamy and scum forms at top due to gases trapped here. Okay. Next, third one, alkaline In alkaline fermentation during this stage, liquid digested solids and gases separated, acids converted by methane, forming bacteria to sludge like methane, carbon dioxide, nitrogen dioxide, and hydrogen sulfide. Generally, in alkaline methane formation, the methane 70% has a fuel value used for power generation to run plant equipment, and carbon dioxide CO2 20 to 25%, 20 to 25%. Okay, so 20 to 25% fuel value used for power generation to run plant equipment, and remaining nitrogen and hydrogen sulfide is remaining. In this alkaline fermentation, biochemical oxygen demand will be fall rapidly so that it will be reduced. Okay, large volume of methane gas along with small amount of other gases are evolved here. Okay, next, coming to the factors affecting sludge digestion, we'll discuss here. First one is the temperature. Rate of digestion is more at higher temperature. Rate of digestion is more at higher temperature. Generally, we know psychrophilic bacteria, mesophilic bacteria, thermophilic bacteria. Mesophilic bacteria, it has the survival temperature between 10 to 40 degrees centigrade and detention time of 75 to 25 days, right? But 90% of this mesophilic bacteria digestion takes place in 30 days only. Okay. Coming to the thermophilic bacteria, the survival temperature will be 45 to 60 degrees centigrade and detention time will be 23 to 18 days. But 90% of digestion takes place in 10 to 15 days. Whereas mesophilic bacteria digestion takes place in 30 days, thermophilic bacteria digestion takes place in 10 to 15 days. So, so both mesophilic and thermophilic bacteria are preferred in sludge digestion process so that we can take optimum detention time as 30 days. Okay, optimum detention time as 30 days and temperature will be 29 degrees centigrade where mesophilic bacteria will act. Okay, so these about the temperature. I told you psychrophilic bacteria which is survive at less than 10 degrees centigrade, which is undesirable in digestion of sludge. But if you take the mesophilic bacteria, it will take the digestion in 30 days and thermophilic bacteria digestion in 10 to 15 days. So generally the optimum time we can take as 30 days. Okay, temperature will be 29 degrees centigrade at which mesophilic bacteria will act. Okay, next coming to the second value, pH value, hydrogen ion concentration in alkaline conditions must prevail here. So optimum hydrogen ion concentration will be 7.2 to 7.4 to encourage bacterial action. To increase the hydrogen ion concentration, hydrated lime is added. Okay. Next, third one, seeding with digestive sludge. Proper seeding helps in balanced condition. Seed the digester with the digested sludge from under tank at startup. Okay. Fourth one, mixing and stirring of raw sludge with the digested sludge. Mixing is done to get a homogeneous mass of raw and digested sludge. Bacteria present in digested sludge will mix with raw sludge and will decompose the sludge effectively. Okay. Under uncontrolled naturally condition, sludge digestion takes place about 4.5 months. However, if the factors are controlled, duration can be shortened. Okay. So here the factors, one is the temperature, pH value. Optimum pH will be 7.2 to 7.4, and seeding with the digested sludge, and mixing and stirring of raw sludge with the digested sludge. Next, another factor, sludge and its moisture content. Generally, sludge from sedimentation tank will be 95% of moisture content. The sludge from sedimentation tank has 95% moisture content. Second one, secondary sludge from trickling filter. Secondary sludge from trickling filter will be has 96 to 98% moisture content. Next, secondary sludge from activated sludge process will be having 98 to 99% moisture content. 95% moisture content means 5 liters solid matter in 100 liters sludge. Okay, 5 liter solid matter in 100 liters sludge. 90% moisture content means 10-liter solid matter in 100 liters sludge. Okay. The sludge with 90% moisture content will be half the quantity as compared to that of sludge with 95%. That means 90% of the moisture content will be the half the quantity as compared to the 95% of the moisture content. That is half 95%. Understanding here? So giving this volume of sludge at moisture content at P1 and P2, here V1 into 100 minus P1 is equal to V2 into 100 minus P2. Here V1 stands for volume of sludge at moisture content of P1 percentage, and volume of sludge at moisture content P2 percentage. Okay. This is about the sludge and its moisture content. The sludge from sedimentation tank has 95% moisture. 95% means 5 liter solid matter in 100 liter sludge. Next, remaining coming to the design considerations. So coming to the design considerations, first we'll consider for single digesters. For single digesters, the cylindrical tank will be considered. Cylindrical tank, cylindrical tank. The diameter will be 3 to 12 meters, and hopper bottom sloping will be, here horizontal vertical ratio is given 1 is to 3. Okay, and depth of the tank will be 6 meters. Capacity of digestion tank is equal to factor of sludge production, digestion period, degree of digestion required, loss of moisture, and conversion of organic matter. Okay. So for single digesters, the detention period will be for 30 days. Okay. Here you mainly understand that for single digesters, in the design consideration we consider cylindrical tank. The diameter will be 3 to 12 meters, and hopper bottom sloping will be horizontal to vertical ratio will be 1 is to 3, and depth of tank is 6 meters, and capacity of digestion tank is the factor of sludge production, digestion period, degree of digestion required, loss of moisture, matter. retention period will be 30 days. Okay, so for single digesters, this is, if you see the two sludge digester, if you see the two sludge digester, two sludge digester used for treating large quantities of sludge. Here there will be a primary digester and a secondary digester, two-stage sludge digester used for treating large quantities of sludge. Here we'll be having two things. One is the primary digester, another one is the secondary digester. In primary digester, the acid fermentation takes place in this primary digestion tank. The detention time will be 7 to 10 days, used for digestion of sludge. Gas produced is collected here, partly digested sludge and supernatant liquid transferred to secondary digester, provided with heating and mixing devices. If you see the secondary digester, here methyl fermentation takes place and detention time will be 20 days. Here detention time will be, in primary digester will be 7 to 10 days. In secondary digester that will be 20 days, used for storage and concentration of digested sludge and for formation of clear supernatant. Okay, so this is all about the design considerations for single digester and two-stage sludge digester. In two-stage sludge digester, there will be a primary digester and a secondary digester. In primary digester, the detention time will be 7 to 10 days. In secondary digester, the detention time will be 20 days. So that's all about the sludge digestion. I will remember things in sludge handling. First, we'll consider the sludge thickening. Sludge thickening will be the water removal and volume reduction. In coming to the sludge digestion, in sludge digestion, the organic matter strength will be reduced and odor will be controlled, and also gas production. If you come to the sludge dewatering, the volume will be reduced. In sludge drying, also volume will be reduced. In sludge incineration, organic matter strength will be reduced. In sludge disposal, we'll consider incineration and land application. Okay, so this is all about the sludge handling system and sludge treatment. Thank you.